So in this class, what we'll do is the homework which I had given in the previous class of trying to solve that maximization problem using simplex method, we'll be doing it, followed by which we'll be trying to understand how sensitivity analysis applies on that. Okay. As of now, I will be showing you pen and paper solutions everywhere because I think that builds more understanding and foundational knowledge. Afterwards, you can also go into the software and check. That is just hardly 1 minute task. So that is something we can always cover in the end. So do not panic if I'm not currently showing you anything in Python or any other optimization software. Okay, that is something we will anyway cover completely in week 7, where we'll be just focusing on Python use cases. Okay. So the problem was, so currently, why is this lagging? I'm not understanding. Okay. So here your original problem was max. This is lagging. Just a second. What has happened to my devices today? Yeah. Max 32x1 plus 36x2, right? Subject to x1 less than equal to 15, x2 less than equal to 25, 2x1 plus 4x2 less than equal to 90, and 2x1 plus x2 less than equal to 48. And x1, x2 is greater than equal to 0. So just like any other problem formulation, the first step that we do is we convert this LP into a standard form, right? So how will it look? That will be max 32x1 plus 36x2 subject to x1 plus s1 is equal to 15, x2 plus s2 is equal to 25. Then we have 2x1 plus 4x2 plus s3 is equal to 90. And finally, we have 2x1 plus x2 plus s4 is equal to 48, right? Where x1, x2, s1, s2, s3, s4 greater than equal to 0. And since this is a maximization problem, so we don't need, so here since this is a maximization problem, right? You do not need the contributions from this slack variables, right? So you will try to keep the coefficients as low as possible. So it doesn't really matter whether you put 0 or 1 e to the power minus 9 or some coefficient like that. Okay. Okay. The next step, what we do? So now we will construct the table. Okay. So what are our basic variables? Can anyone tell me from here?
So the basic variables here would be S1, S2, S3, and S4.
Very good.
Because these, their values are 1 in exact one equation and zeros
Yes.
in the other equations.
Yes, absolutely. Okay. And what are your non-basic variables?
So only remaining ones, X1 and X2.
Very good. Yes. So now when you first make the table, okay, so this is my first iteration, right? This is my basis, XB, okay. Here I have XJ, CB by CJ, okay. So here you will have X1, X2, S1, S2, S3, S4. Here this is my right hand side. What are the coefficients I have? 32, 36, 0, 0, 0, 0. Okay. Now in the basis, what values will you have? S1, S2, S3, S4. Okay. I'm not drawing the lines. Is that fine? Because anyway, drawing the lines will...
Yes.
Yes, fine.
Huh?
Yes,
It's fine, right? Okay. Okay. So here it is 0, 0, 0, 0. Okay. On the right hand side, what all values we have? 15, 25, 90,
90 and
40. Yes. Okay. And here, what all do you have? So x1 plus s1. So rest all 0. Then you have x2 plus s2. Then you have 2x1 plus 4x2 plus s3. Then you have 2x1 plus x2 plus s4. Right? So now when you calculate zj, they are all 0 because anything multiplied by a 0 is a 0, right? So Cj minus Zj
yes.
currently is your 32, 36, 0, 0, 0, 0. Up till this, all of you got, right?
Yes, yes, yes.
Yes,
Okay.
ma'am.
Now, see, this is a what kind of a problem? A max
Maximization.
one. A max one, right? So I would try to bring this to the Cj minus Zj values to negative. Which was the highest Cj minus Zj value now? 36. So we try to choose this value, right? Just like in the previous simplex method you were
Yes.
doing. And now, since we were choosing this, what is the next step which you will be doing? Can anyone tell me?
So we will
Taking
replace.
the ratios of RHS with
Taking the
the
ratios of RHS. Very good. So the next step that we do is taking the ratio. So let's say here only I write the ratio. Okay. So my point of interest is this column, right? So 15 by 0 does not make any sense. So blank. 25 by 1 is 25. 90 by 4 is how much? 22.5.
22.5.
And this is 48. So which is the lowest ratio, minimum ratio? 22.5. So we will select this row. What does this mean now?
So this means that
4 would be the point of pivot,
X,
Uh,
and S3 would be replaced by X2.
yes,
X2 will be replaced by S3.
This S3 will be replaced.
Ha,
S3 will be
I mean,
replaced by.
yes, S3 will be replaced by X2. Yes, yes, yes. Right.
But
So,
I have queries here at this point. So I mean, first thing is that why did we consider the highest value of Cj minus Zj? So basically, what this Cj minus Zj is reflecting here, number one. And while computing that which variable is going to be removed from the basis, we took the one whose ratio value is minimum. So what this ratio
that is
thing,
something I explained in the last class, why we are taking the minimum positive ratio.
you explained this thing, but that was for the minimization problem and that was well understood. But somehow I could not understand that for the maximization one, why are we taking the value, the maximum value?
See, you can take 32 also and you will arrive at the same thing, right? But here, what is your objective? For example, in the previous simplex method, when we had a minimization problem, our objective was so that the reduced cost value should turn positive. Only when the reduced cost value turns positive faster, that means that we are reaching the optimality. So for a maximization problem, when your reduced cost value becomes negative, that means you have reached optimality. Now, this is the maximum value, 36. So you would want to make the maximum value negative first, right? That is a simple logic, a simple intuition. It is nothing where it is specified in your books that, okay, this is the rule book. You can choose 32, you will arrive at the same value nonetheless. But I'm
Yes.
trying to bring the values closer to less than equal to 0. So this is higher value than 32. So I'm trying to bring this value first to 0 or at least less than 0. And then I will try for the 32. Simple logic, nothing complex in it.
Yes. So when you say that Cj minus Zj negative, so which negative? I mean, so
I'm
in
not
in
getting your point. What?
even just now you said that we will take the value which will make the maximum negative. So what negative? Uh,
Cj
is it-
minus zj value would be negative. Did you understand simplex in the last class?
yes, yes, I understood. So Cj minus Zj is negative, but then none of the value is negative here. All the values are positive, isn't it?
It is not called positive. It is called positive. That. What does that indicate? That means that you haven't reached an optimal solution, right? See here, what we were trying to do. Here we were trying to. What we were trying to do here. Here we were trying to consider the maximum negative value and then try to convert these into positive. If you see these lines in the previous classes, this is what we were trying to do.
Yes.
So
And
here
now,
maximization problem. So in the maximization problem, you are trying to convert this into 0 or less than equal to 0. Your reduced cost value of the non-basic variable should be less than equal to 0 for reaching optimality in case of a maximization problem.
yes, and we pick the value 36. So what does it mean? What this 36 is indicating here? I mean, what does it mean that?
I think I'd explained this in the previous classes very well. What does reduced cost mean?
Yes,
What
yes,
does, because every time if I keep on repeating, anyway, it will eat up the class time.
yes, yes, right, right. You are right. So you continue, then I'll refer the previous class again. Then. Fine.
Yeah. Okay. So, Divyanshu, are you clear or are you also having doubts?
Ma'am, I am clear regarding that why we are taking 36 as a number, because it is the highest factor to which we need
Mm-hmm.
to reduce, bring whole question into towards the optimum solution. That I understood. Other
Okay.
things I will study on myself and then.
No, but what things did you not understand?
No, ma'am,
Eh,
not any point right now that I'm able
Oh,
to capture. But
fine,
if
fine.
there are any doubts, I will come back.
Okay, fine. So this is 36x2 now. Your values become, okay, now, first thing first. So, as I had said, now what will you do? Now you will try to make these columns similar to what? 0, 0, 1, 0, right? Because x2 has entered your basis. So, we will do elementary row operation. So, R3 will become R3 by 4 first, right? Because we are trying to convert this into 1. So, this will become 2 by 4 means half, 1, 0, 0, 1 by 2, 0. And this also becomes 90 by 4. Okay. Always remember any changes that you are making in your table. Do not forget to make changes to your right hand side as well. Okay. Okay. Now this is 1. Next, we can do R2 as R2 minus R3 because currently your R2 here is 1. So 0 minus half is minus half. 1 minus 1, 0. 0 minus 0, 0. 1 minus half, 0. And this becomes 25 by 4 minus 90 by 4. So that is 100 minus 90 by 4, 10 by 4. Okay. Next thing you have is your R1. So R1, you don't really need to make any changes because anyway it is 0. Okay. So you can simply write 1, 0, 1. R1 stays R1. 1, 0, 1, 0, 0, 0, 15. And here you need to again make changes. So this, what you can do is R4 is R4 minus R3. So that is 2 minus half. So 3 by 2, 1 minus 1, 0. Again 0, 0, 0. This shall be, okay, I think I made a mistake here. This should have been, nobody pointed it out. It is 1 by 4, right? So if this is 1 by 4, this would also be 1 by 4. So this would be 0 minus 1 by 4 minus 1 by 4 and 1 minus 0, 1. And 48 minus 90 by 4. So 48 into 4 is 192 minus 90. So that is 102 by 4. 1010. Right. This part is fine. So now if you calculate ZJ, you will be calculating basically for this because you have a coefficient here. So 36 into half is 18. 36, 0, 0, 9, 0. Okay. And here, what are the values you're getting? 36 into 90 by 4. So that is 810. Here, ultimately, you arrive at the objective function value. That is why we compute. Okay. Otherwise, while calculating Cj minus Zj, that thing plays no role. So now your Cj minus Zj is 32 minus 18, C 14. Now you have converted this to 0, 0, 0. This shall be 0 minus
Minus
9.
9.
That is what I was thinking. This shouldn't be minus 9, right? This should also be 0.
Ma'am, if ma'am S4 value for in S4 row and S3 column, the row would be minus 1 by 16.
Where?
S4 row and S3 column means
S4 row
ZJ value is 9.
and S3 column. Okay, this one you're saying?
Yes, yes.
Okay,
Would
so
it
this
be
is
minus 1 by
4
16?
minus 3. No, it is 0 minus 1 by 4 here. No, so that is minus 1 by 4.
Okay, so I might have used different operation then. That's why
Hmm.
I'm getting.
Okay, yeah, this is fine. This is minus 9, 0. Okay. I got confused for a second. Anyway, see, for reaching optimality, your Cj minus Zj values in a maximization problem have to turn out to be 0 or less than equal to 0, right? So this is fine. Okay. Now the same thing that we do. Okay, Divyansh, are you clear?
Yes, ma'am. But my overall optimum value which I've got, that is different in this iteration. My
I don't know, maybe
CJ
the
minus
calculation.
ZJ were similar, but optimum was different.
This one.
That I will verify on. Yes,
Okay,
yes,
fine.
yes. I
What
have
is it?
gotten different.
Fine, fine, no problem. Goel, sir?
Yes, yes, it is clear to me. Yeah. So this
Okay,
time we are
fine.
going to select X1, isn't it?
Yeah, 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 yes.
Okay. Yes, yes.
So now again, you do the ratio. See, now we have this value, this column, I mean, see, because you have 14 here. So simple thing, we will do what? See, 10 by 4 by minus half doesn't make any sense, okay? So we do nothing about it. 15 by 1 is 15. 90 by 4 by half, that is 90 by 2, so 45. And here you have 102 by 4 by 3 by 2, so that is so that is 34 by 2, 70. So now this is the minimum ratio, okay? So you choose this, S1. And what is that you do? Now,
Um,
now in your third iteration, X1, X2, S1, S2, S3. Okay. Now in your third iteration, you will
yes,
replace S1 with X1, right?
yes, and the row values would remain the same. I mean, row
Yes,
operation.
yes. So X1, S2, X2, S4. I hope this is going to be the last iteration. Okay, let's go on. So X1 now is 32, 0, 36, 0. Okay. Now see, now this thing has to look like this. Okay. So what are the changes that we do? So first thing first, the first one stays the same because R1 doesn't have to be, you don't have to make any change. It's anyway 1. So this is 1, 0, 1, 0, 0, 0, 50. Okay. You can do one thing. R2 is R2 plus R1 by 2. Okay. So now your R2 is minus half plus half, 0. 0 again. This would be 0 plus half, half, 1 minus 1 by 4, 0. And this would be 10 by 4 plus 15 by 2. So that is
10.
40 by 4, 10, right? Okay. Now, what you can do is R3 as R3 minus R1 by 2. So that would be half minus half, 1, 0 minus 1 by 2, 0, 1 by 4, 0, and this would be 90 by 4 minus 15 by 2. So that is 90 minus 30, 60 by 4. Okay. And lastly, here also it should be 0. So here what you can do is R4, R4 minus 3 R1 by 2. So 3 by 2 minus 3 by 2, 0, 0, 0. 0 minus 3 by 2, 0 minus 1 by 4. This is 1 and this is 102 by 4 minus 3 into 15. 45 by 2, right? So that is 102 minus 90. So that is 12 by 4, 3. Okay. Now if you calculate values of Zj, that is, oh, sorry, I forgot to mention CBCJ. So that is 32, 36, 0, 0, 0, 0. So now your Zj is 32, 36, 32 minus 18, 14. Here it would all be 0. Here it would be 36 into 1 by 4, 9. And again 0. And here you will be getting 32 into 15. So that is 450 plus 30, 480 plus 36 into 60 by 4. So that is 450. I think I'm making any mistake maybe. So 15 into 32 is 480 and 36 into 60 by 4. So it's fine, right?
480 plus 540.
Uh,
Instead of
Sorry, yeah,
450,
yeah, yeah. This is,
540.
yeah, yeah. Thank you so much. Yes. So this is 480 plus 540. So that is 1020. So here you are getting 1020. And here your Cj minus Zj are C. 0 minus 14, 0 minus 9, 0. So you have reached your optimality. Okay. And this is your objective function value. Simple. That's it. So now your basic variables are x1 is equal to 15, s2 is equal to 10, s2 is equal to 10, x2 is equal to
15.
15 again, and s4, yeah, this is 15, and s4 is equal to 3. Okay. Non-basic variables are s1, s3. Okay. because they do not appear. So that is 0. Objective function value is 1020. So first thing first, my optimal solution is non-degenerate, right? Why? Because the number of basic variables that we have is strictly equal to the number of constraints in our LP model. Okay, number of basic variables having a strictly positive value. So your optimal solution is non-degenerate. Second, we have a unique optimal solution. Always remember, when do you have a unique optimal solution for simplex? If the reduced cost value of each of the non-basic variable is strictly positive or negative depending on the nature of your objective. So here it is a maximization problem. S1 and S3 are my non-basic variables. My reduced cost value is strictly negative. So it is a unique optimal solution. Had it been 0 also, let's say it is 0 and this is minus 14, still it would have been a unique optimal solution. Okay, I'm not saying. But had both been 0, then you would have a multiple optimal solution. Okay. Which constraints are binding? See, S1 and S3 is equal to 0. That means here, in your original standard form, this S1 and S3 are 0. That means constraint 1 and constraint 3 are binding. Okay. So this means constraint, I think I have to, it's lagging. Constraint 1 and 3 are binding. Okay. Similarly, constraints 2 and 4 are non-binding. Okay. So now you have gotten this idea. Okay. Now we will try to apply sensitivity analysis. Okay. Our next topic is sensitivity analysis. So what is sensitivity analysis? Okay. So now the input data that you have related to any kind of uncontrollable variable for most linear programming models, okay, they would often only be estimates. Okay, you are never going to get an accurate quantity. Okay, this is my price, this is my cost. In a real life scenario, you might have such costs defined. For example, here we had 32, 36, all these values. But in real life, scenario is pretty different. Okay, so we call them parameters. Okay, so let's say here, okay, if I go back, this must have been, let's say, some price of some product X1, price of product, not X1, price of product A, price of product B. Okay, so X2 and X1 were respectively the number of quantities of that product. This might be changing. Okay, then your resource constraints on the right hand side. Okay, for example, 15, 25, 90, 40. This also might be changing depending on your real life scenario. So every time when these values change, you would not go back and resolve the entire model. Okay, so this is where sensitivity analysis comes into handy. Why? Because we are measuring the sensitivity of the solution when the input values change. That is why it is called sensitivity analysis. Okay. Further, because this analysis takes place after we obtain the optimal solution to the original, so you can also call it as post optimality analysis. Okay. Now, in this week, Okay. I don't know if I can cover this. See, so sensitivity analysis is a very broad topic. Okay. So you can always go back and see from the book. But in this week, we will try to investigate the sensitivity of the solution for the following input changes. Okay. One at a time. First one is when the objective function coefficient changes. Okay. What time? When the coefficient of variables are not in the optimal solution. So that means coefficient of the non-basic variables as well as the coefficient of variables which are in the optimal solution. Okay. So that is basic variable. First thing. Second thing, when your constraint values change. So if your constraint value is changing, that means what? There is a change in resources. So either you will be trying to see what is happening to the non-binding constraints in the optimal solution, okay, where your slack or surplus or excess is greater than 0, or binding constraint where your slack or surplus is equal to 0. Okay. Third is adding a new activity. Okay. Then how will it affect your optimal solution? So as I was saying, reformulating the model and resolving could become too laborious and expensive. Okay, we also call it the brute force method. So what you can do is you can use the information which you are obtaining in the final. So this is my final tableau of simplex procedure. So you can always deduce information, most of this at a relatively cheaper cost or effort from the final table of the simplex. And remember, there is a small constraint. This is possible only when the change falls within some interval. Okay. So we also call it, we have different names for it. We can call it allowable range, okay, or range of feasibility, or range of optimality, or permissible range. Okay. So now what is that range and everything? That is also something that you will understand. Okay. So let's try to solve the first thing. Okay. So are you all in it with me? Are you all getting whatever I'm saying? As of now, any doubts?
So can you explain the purpose? I mean, why are we doing the sensitivity analysis? Is this because we want to check that how the solution will vary if I make a tiny change in the input variables or what?
Yes, yes. Not in the input variable, like let's say in your resource constraints also, okay? For example, let's say tomorrow you have maybe just 13 machine hours, but when you solved your model, you had 15 machine hours. So now you want to see whether in the 13 machine hours your solution is still optimal or not, okay? So you won't want to reformulate your entire model and then solve it, wasting your time. Okay. So what you try to do is you basically try to find out the what should I say, the possible range of values which your existing variables can take, within which you will still retain the optimality of the solution.
Ah, so what's
Okay.
the meaning? Yeah, so retaining optimality, because if I change the coefficients of the variables x1 or x2, clearly I will be
Yeah.
getting a different optimal solution.
Obviously, you might or you might not. Let's say for non-basic variable, if you change the values within a permissible range, your optimal solution is unaffected, right? Because they do not contribute to your objective function value.
Right.
What I mean is the objective function value does not change. Okay, but
Yes.
your basis might change. Your basic variables might change. So what are going to be those changes? That, see, I will solve a simple example so then you will understand. Okay. So let's say we take the first case. My first case is the objective function coefficient changes. Okay. So now, if only I could copy this, it would have been great. I don't think I can copy this. What happened? I'm sorry, I think. Mhm. Okay, I think I just calculated on. Can I copy this? Okay. No, I guess I cannot. Okay, no problem. ठीक है. I will just add another page. Okay. So let's say what I want to see is what changes can be brought into the value of x1. Okay. So currently your, sorry, I'm so sorry. So currently your LP is max 32x1 plus 36x2, right? Subject to x1 less than equal to 15, x2 less than equal to 25, 2x1 plus 4x2. Okay. I want to see that how much change can I make in the objective function coefficient of x1 so that my optimality remains the same. Okay. So what I can do is I can simply write it as max 32 plus delta C1. Just this part will change. X1 plus 36x2 subject to everything else remaining the same. Now, this is what was your final tableau, right? This. So here, you don't need to solve everything. What you need to do is, first thing first, either you can solve iteration wise, like everything, adding, or you can simply consider the final table of the simplex procedure and then do your calculation. So let's say if I add here that this is my 32 plus delta C1. Do you want me to make this table again and then solve it so that it's easier for you to understand? Instead of doing the scribbling here?
Yes, that can be done. You copy this table from here and then
Yeah,
paste.
that's what I'm not able to understand. How do I copy this table? It would have been really easy for me. Just give me a second. Maybe I'll just check it. How can I do it? Hmm, I think I think here. No, I think here I can't do it.
Uh, so there are three dots here. If you could press
Yeah,
escape.
I did try, but nothing is coming up. Yeah. Then
Then there is no option to select a region.
um,
Probably if you one more, you can give one more try by clicking these four rectangles. I mean towards the left of the three dots. Press it here.
no, it's
Oh,
just pages.
oh,
Yeah. Yeah, there is nothing I can do. I will just how
you
do I
simply
call
simply select region through your stylus and then right click on it and see if it works. Simply select this region. Uh, oh, nothing is nothing can be done. No
No,
option.
it is not taking only. It is not responding. Okay, no problem. I'll just make the table again. So we'll just make the final table, okay? Just remember, we don't have to do everything. So how did your final table look like? So this is your basis. This is xj, cb by cj. You have x1, x2, s1, s2, s3, s4, okay? Again x1, s2, x2, s4. x1 I'm not touching as of now. s2 0, x2 36, 0. X1 also, I'm not putting the coefficient. I just want to put it in a different color. That is why 36, 0, 0, 0, 0. Can you tell me the values that we had in the final table? So here we have 32 plus delta C1. Here also we have 32 plus delta C. I think since X1 and all these have entered the basis, so X1 would be here. It should be 1, 0, 0, 0. For S2 also, it should be 0, 1, 0, 0. X2 should also be 0, 0, 1, 0. S4 should be 0, 0, 0, 1. What about the other values? Can you tell me in case you guys have solved it? So you have 1 half, minus 3 by 2, 15, 10, 15, 3, and okay. So here you have 1 half, minus 3 by 2. Your right hand side had 15, 10, 15, 3. This was something as 0, minus 1 by 4, 1 by 4, minus 1 by 4, if I'm right. Okay. Now the only thing that you need to do is, see, this is the only change that we are making, right? So now when you calculate Zj, you'll be getting 32 plus delta C1, then 36, then 32 plus delta C1 minus 18. So 14 plus delta C1, rest everything again, 0. This is 9, 0. And here you will be getting what? 32 into 15 plus 36 into 15. How much had we gotten? 1020 plus this 15 into delta C1, right? Are you able to see my screen?
Yes, yes. Well,
Huh. Are you able to understand?
yes, I could understand. Yeah, I could
Yeah.
understand.
Yeah. So now it will become 15 into delta C1. Now if you do Cj minus Zj, you'll be getting 0, 0, minus 14 minus delta C1, 0, minus 9, 0. Now, as per the optimality condition, since it is a maximization problem, right? So your minus 14 minus delta C1 should be less than equal to 0. That means delta C1 should be greater than equal to minus 14. That means 32 plus delta C1, right, should be greater than equal to 18. That means the coefficient of x1 in order to retain optimality should vary from 18 to infinity. And in case it varies, your new z value will become this. Okay. New z value is nothing but old z value or objective function value plus the value that you have of x1 into value of delta C1. So that means it would be in this case 1020 plus 15 into delta C1, and delta C1 can vary from -14 to infinity. Got it? So this is one kind of a sensitivity analysis where we just try to assess what happens when your, this was our first case, right? When your objective function coefficient changes. What about 36 x2? If I have to see, how will that impact? Can you do it now? So now I want to see, okay. So now I want to see that, so this was first case, okay. In the second case, you want to see max 36x1, sorry, 32x1 plus 36 plus here some delta C2, x2, subject to all the constraints remaining the same. Okay. Now if I make the table, see your final table structure will remain the same. The only manipulations you will have to do is with the coefficient and Zj and Cj minus Zj, and this right hand side you will have to compute. So let's do it. We have basis. After this, I will just take a small break of 5 minutes and then we'll come back. So I do basis, Xj, Cb by Cj, X1, X2, S1, S2, S3, S4. And here you have X1. So now your X1 is untouched, 32. Also remember, you cannot make the changes simultaneously. In this sensitivity analysis that we are learning, you cannot make the changes simultaneously in the objective function coefficient, okay? Then you won't be understanding. That is why I mentioned it earlier, one at a time. Okay, here we are doing the changes one at a time. When you will be doing the changes simultaneously, there is something known as the 100% rule, which if time permits, I will teach you, but that comes a lot later, not now. Okay. So this is 32, 0. This is also 0. Here also 32. This I keep blank. 0, 0, 0, 0. Okay. Uh, Here it becomes 36 plus delta C2. Here also it becomes 36 plus delta C2. Okay. Now, rest of the values remain the same. So in this case, you have 1, 0, 0, 0, 0, 0, 1, 0, 1 half 3 by 2. Right hand side, you have 15, 10, 15, 3. Okay. Now, if you compute Zj, what you will get? 32. Then here what you will get?
36 plus delta C2.
Yes. Then here you will get 32.
So here we will get 52 plus delta C2.
14 minus delta C2 by 2. Okay. Yeah, 32 minus 18, 14 minus delta C2 by 2. Here you will get 0. Here you will get 9 plus delta C2 by 4. Here again you will get 0. And here also you will get 1020 plus 15 delta C2. So if I do my Cj minus Hj, 0, 0, minus 14 plus delta C2 by 2, 0, minus 9 minus delta C2 by 4, 0. And as per the optimality condition, your reduced cost value should be less than equal to 0, right? So minus 14 minus plus delta C2 by 2 should be less than equal to 0, and minus 9 minus delta C2 by 4 should be less than equal to 0. So what do you get out of this? So this means delta C2 should be greater than, no, delta C2 minus 28, right? Less than equal to 28. And here you will get 9 into 4 minus 36. So minus 36 less than equal to delta C2. So that means between minus 36 and 28, it will vary. So that means 0, 36 plus C2, and 36 plus 28 is 64. So this is your allowable range of optimality. So that means no change in basis, no change in the values of the basic variables. See, basic variables values also remain the same. Basis remains the same, but there is a change in the objective function value. Okay. So remember, in both these cases that we did, x1 is a basic variable, x2 is also a basic variable. So when there is a change in coefficient of a basic variable within the allowable range, okay, always remember this has to be emphasized no matter what. Within the allowable range, if you are having a change in the coefficients of a basic variable, there will be no change in basis, no change in the values of the basic variables, but change in objective function value. Okay, which is nothing but something that I already mentioned here. New z value is old z value plus value of the basic variable into value of that permissible range. Okay. In the case of a non-basic variable in the objective function, okay, basis will remain the same. Values of the decision variables will remain the same. And value of objective function also remains the same. That is not something I'm writing. That is something that you can try out as a homework. Okay. Try it out so that you get more understanding. Try to change coefficient of a, in this simplex uh, table only, you try to change the coefficient of a non-basic variable and then you see what happens. Okay. So this was the first case that I wanted to discuss. So I have discussed only for a basic variable. Okay. You please try it out for a non-basic variable that is left for you as an exercise. The next thing which we will try out after a break of 5 minutes is when the right-hand side value changes. Okay. So when there are changes in the resource constraints. Okay. So I'll see you just in 5 minutes. Till then, you can try for the non-basic variable if that works. Is that fine?
Yes.
Yeah. Okay. So now what I want is the next. So the first thing is clear with both of you, right? When we are trying to change the objective function coefficient.
Yes, but then even if I make the changes in the basic variables, say S2 and S4, I mean, what would be
Mm-hmm.
the point of investigating in making a change in S2 and S4? Because S2 and S4 are the slack variables and they do not exist, I mean, at the first place. So, I mean,
S2
why?
and S4 are your basic variables, so they are on non-binding constraints. So you can see that you won't really find much changes.
So they are non-binding constraints. So, what did you say? I could not hear. Uh, So my query is that I mean, what would be the purpose of carrying out? I mean, such a I mean, analysis such an analysis for the variables S2 and S4 because they are not physically existing variables.
No, they are in your constraints, right? They are not binding constraints, they are your non-binding constraints. So you can always try it out to see here, let's say your S2 and S4. Here, let's say there are some kinds of changes. Physically, there won't be anything because they are not contributing to the objective function value. Okay, but just for your learning purpose, you can see. That is
Okay,
why we don't even show it in the, I mean, I did not show it here while I was teaching.
okay, all right.
Okay,
And
yeah.
yeah, and similarly for the non-binding ones, I mean, so for the non-basic variables, and since their coefficients are zero, so I mean, they won't be making any difference if I make some changes here and there.
Yeah, I think you should try it out and see. Won't
Okay.
answer now. Maybe in
All
the
right.
next class we can discuss. Okay. Yeah.
Yeah.
Okay. So now what I want to do is I want to conduct this sensitivity analysis when the right hand side value of the constraint changes. Okay. So now let's say this is my model. Some delta B1 on the right hand side. And okay. Now what will happen? That is what I want to know. So any guesses what we can do? So again, just like previous case, we would be focusing on the right hand side of the table. But there are certain changes which will be done. Can anyone tell me what?
So there would be a change in the ratio, and so we'll have to check that whichever variable is being removed, it is still removed if I make the changes in the right hand side. That will
So I
give
will tell
the
you what is happening.
yes.
So your basis is okay, I'll just make it here only. This is your basis, right? Xj, Cb by Cj, x1, s2, x2, s4. 32, 0, 36, 0, right? x1, x2, s2, s3, s4, and this is your right hand side. Okay, follow very clearly. So here you have 32, 36. Now your right hand side here becomes, so S1 is corresponding to which constraint? this change is corresponding to which constraint? The first one, right? So here you have 15 plus delta B1. Your right-hand side values are now going to change. What will happen? This will become 10 plus half delta B1. This will become 15 minus half delta B1. And this will become 3 minus 3 by 2 delta B1. And this objective function value, right? So now if you calculate Zj, your Zj is what? 32, 36, 14, 0, 9, 0. The same thing, Cj minus Zj is 0, 0, minus 14, 0, minus 9, 0. You basically want to retain the optimality. So your objective function will also become 1020 plus 14 delta B1. Now this is something which you can verify from the first iteration, okay? See, for your purpose, I won't be showing it to you. You might initially think, okay, we had just 15 plus delta B1. Why is she changing all the other values? What you can do is, in order to understand that why we are ultimately multiplying these values by the column values of S1, what you can do is consider from the first iteration of the simplex table, okay? You can do this on your hand. This is your another homework which you can do. Consider from the first iteration. Okay, and then just put here 15 plus delta B1. As you go on keeping this delta B1, as you go on doing these changes, you will understand that slowly, slowly everything starts, because see, it is very obvious, like you are doing this row-wise eliminations. These row-wise eliminations not only impact your values here, but it also impacts the right-hand side values. So when you ultimately arrive at the
Yes.
third iteration, huh? Divyanshu, you were saying something?
No, 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 nothing, nothing.
Yeah. So this is for you to work it out so that you will understand when you finally arrive at the third iteration, this is how it looks like. So ultimately, all the corresponding values of your S1 will come on the right hand side. Now, since you already know simplest, I won't be doing it. But just to check why these values. So this is, see, 1 into delta B1, half into delta B1, minus half into delta B1, minus 3 by 2 into delta B1. The moment you introduce delta B1 in the first iteration of your simplex, and you keep doing the iterations, you will see you ultimately arrive at this. But for solving it in a faster way, this is the way you have to do it. How we are arriving at this is something which you can do using your simplex. You can also check this. This is your another homework. Check how you're arriving at this iteration using simplex. Got it?
Yes, yes.
Yeah. Now, if I want to know the values of delta B1, can you tell me what will it be? So what are these right-hand side values?
So, except the first thing, all other things, all other values like 10 plus delta V1 by 2 and the remaining values, these values should be
Should be.
yes. So I was trying to, because this entire thing should be less than or
Hey,
equals to
why you
50.
are leaving the first one? All are the values of your basic variables, no?
Yes, so all
Everything is a basic variable.
yes, so all values should be less than equals to 15 plus del V1.
Should be greater than equal to 0,
Uh, yes, 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 right.
right? Values of all the basic variables should be greater than equal to 0. So your value of x1 here is what? 15 plus delta b1. S2 is 10 plus delta b1 by 2. X2 is 15 minus delta b1 by 2. And S4 is 3 minus 3 by 2 delta b1. So everything has to be greater than equal to 0. So if I solve this, the first one I get is delta B1 greater than equal to minus 15, delta B1 greater than equal to minus 20, delta B1 less than equal to 30, and this one would be 6 minus 3 plus 3 by 2. No, sorry. Sorry. What am I doing? This would be 3 delta B1 by 2 less than equal to 3. So delta B1 would be less than equal to 2. So if I have to arrive at the common region, what will it be? Minus 15 delta B1 less than equal to 2. Right? Basic maths. So this was what? Your S1 was a non-basic variable or a basic variable? First tell me. S1 was a non-basic variable. That means S1 value was 0. That means your constraint was binding.
Yes.
So
First constraint.
when there is a change in the right hand side value of a binding constraint, I again repeat, within the allowable range. See, if this is the range within which your values are getting, your values are getting changed. Otherwise, if it is outside this range, you will have to resolve the model. No other solution. But if it happens, then no change in basis, but there is a change in values of basic variables, because now if you see your x1, let's say your delta b1 is 2, x1 will become 17, s2 will become 10 plus 1, 11, like that. Okay, so changes in values of basic variables as well as change in objective function when your constraint is binding. And what is your objective function value? That is nothing but old objective function value plus, remember, dual price. Okay, these are all dual prices into the value of delta B. So what is dual price? From here only, slowly, we will try to build up the concept of duality. Okay, that is something probably I'll cover tomorrow or maybe the day after. Maybe in the next week. So what is dual price? Anyone has an idea? So I will just give a definition, a small definition for you to understand. We call it dual price or marginal price or shadow price. What is it? That is, I had repeated, rate of change of objective function value for every unit increase or decrease in right hand side of a constraint. Very important. Rate of change of objective function value for every unit increase or decrease in the right hand side of a constraint. Okay. Now, one thing that you know is that non-binding constraints, non-basic variables, right? They do not really contribute to your objective function value. So can you tell me what will be the dual price of a non-binding constraint?
Ma'am, please repeat.
So what will be the dual price of a non-binding constraint?
Zero.
Yes, always. Okay. Non-binding constraint ka dual price is always going to be 0. It is going by the very basic definition of a dual price, right? Okay, I think or maybe I can solve another problem. That's what I'm thinking. Hmm. Okay, let's say this was a binding constraint, right? Let us try to change the right hand side of a non-binding constraint. Okay, and that's the final thing I think we'll do in today's class. So, hmm, every time this lags. What is that? Okay, so now we are trying to change the right hand side of a non-binding constraint. Okay, so let's say we will change x 30 to x1 plus. I mean, the concept is the same, but yeah, just to show you, x1 less than equal to 15, x2 less than equal to some 25 plus delta b2, 2x1 plus 4x2 less than equal to 90, 2x1 plus x2 less than equal to 48. Okay, so just like previous times, what will we do? We will just make the right hand, we'll just focus on the final tableau. Okay, and what is there in the final tableau? If you see here, okay, let us make it from here only. So, okay, wait, I'll just make the basis xb, x1, s2, x2, s4, cb by cj. So, right hand side 32, 36. So, x1 would be 1, x2 would also be 1, s1 is 1 half minus half minus 3 by 2. Again, this is lacking. Then you have s2 as 0, 1, 0, 0. Then you have 0 minus 1 by 4, 1 by 4 minus 1 by 4, 0, 0, 0, 1. Right? Okay. Right hand side, you will have. Is my voice echoing?
No, no.
That's fine, right? Okay. Now you have in the right hand side as. So, see, now this corresponds to S2. Hai na? So, initially in your right hand side, you had 15, 10, 15, 3. Now this becomes 15 plus 0 into delta B2 plus 1 into delta B2 plus 0 into delta B2 plus 0 into delta B2. Your Zj is 32, 36, 14, 0, 9, 0, 1, 0, 2, 0 plus this thing, delta B3, delta B2, sorry. And Cj minus Zj is 0, 0, minus 14, 0, minus 9, 0. So all the values of the basic variables should be greater than equal to 0. So that means 10 plus delta B2, because everything else is 0 here, should be greater than equal to 0. So delta B2 should be greater than equal to minus 10. So if, this is what I
Nice.
mean, if the right hand side of your constraint, okay, is changing within this allowable range, there would be no change in basis, but change in the basic variable. But, oh, this is also 0, sorry, but no change in the optimal solution. As you say, it will remain 1020. Okay. So if I have to summarize, what can I write? Do you want me to write the final summary, or you have understood?
Please write this. Yeah, final.
Okay, fine. So in order to summarize, okay, if we are changing right hand side of a binding constraint within the range of optimality, okay, that is something I'm not writing. Basis remains the same. Values of basic variables change, as you saw, and value of objective function will also change. But if there is change in right hand side of a non-binding constraint within the range of optimality, basis remains the same. Value of basic variable will change, and values of objective function will not change. Okay. So this was to give you an idea of how basic sensitivity analysis works, followed by simplex. Okay. Now, one thing which I can do is I can give you a problem and you can try solving it. Maybe in the next class we can discuss it if time permits, but for your knowledge, you can do it. Shall I share the problem?
Yes, yes.
Okay,
Yes, ma'am.
just give me 1 second. Maybe I'll stop sharing my screen.